And we could use that. Like, it's just the
ACC is not
we don't
obvious.
use abbreviations.
Yeah.
And
Okay.
Yeah, so
accumulate them.
Addend or accumulate or something that makes it clear it's the thing being added.
yeah.
All right. So, sorry. Which one did we make any changes?
Change ACC to either accumulate or addend. Addend might be more clear than just accumulate.
How do you spell addend?
ADDEND.
Okay.
Just since accumulate is a verb, not a.
I mean, I think that in Link, I think we call it accumulator, but like, not sure we care enough.
I think you're right. Yeah.
Oh, if we've got prior art for calling it accumulate, that is the term ARM uses.
Yeah.
So
I'm just disagreeing with ACC.
yeah.
So then, let me. If anybody checked that what I said is actually true. Which one is it? Is that I think it's the come on.
I have no clue what function would have that.
I think it's the link accumulate function. Enumerable dot, what is it? Accumulate? I can't spell the word apparently. That's might be my problem.
I don't see one. I see some, but that just takes source over an IEnumerable.
Oh, sorry, aggregate. Never mind. Oh, we take a func, never mind it. T accumulate is the data that we pass in.
Yeah.
But that's suggesting modification, and this is being used as a value.
Yeah. I mean, you could call it accumulator if you cared enough, but like I mean, addend. I mean,
Yeah.
I mean, I don't think any of these APIs will be used by somebody who just stumbles across them anyway. So as long as you can know what it is, if you already know it.
Yes, really the important thing, especially for the absolute difference add, is understanding which two things are being subtracted
Yes.
and which thing is being added on the end.
Yeah.
And, but I think that a name like accumulator suggests that it's
Continuously added.
ref as opposed to
Yeah.
just a value. So I think added
Added, yeah.
is a better
All right.
name for its purpose.
Let's go with added. And then
So no subtrahend on the other
this
side.
one we approved. Let me know. Let's go.
I mean, we can name left and right something else, but
Actually, I like left and
Subtrahend
right.
minuend, I think those are the two
Subtrahend
terms.
and
Yeah.
minuend.
Oh God.
No.
yes, and then everyone would have to look up what those terms mean.
Exactly.
Then we can add in augend as well.
Ooh, I'm liking the kind of like B shape that your T's make on the vector of whatever. Screen's very fuzzy from back here, so they just make.
It's pretty awesome.
I see I B B B or I B B I B I B I. So that's all it says to me from back here.
Whenever
Alright.
you're done, Emil.
Sorry, what?
Are you
600
done? Or?
point.
I'm yeah.
Okay.
I think
You can sit up front if you want.
I could.
So the next one is add pairwise. For x86, this is called horizontal add. They functionally do the same thing. Pairwise is the term ARM uses.
works for me.
Is the comment makes it sound like the operation's defined only on bytes.
I think that might just be an issue with the comment.
Okay.
Let me
Yeah.
pull it up and double check.
I think byte probably refers here to element, right? And I suppose the multipliers are the same, right?
Yeah, it's
Because you're talking about pairs. Right?
it's functionally operating on pairs, not bytes.
Okay.
Yeah. Byte is by
Where
usual
byte
short
should be
and-
element is the term.
And then same thing, we don't support long, U-long, or double, right?
Right.
So there is scalar version that operates only on one source register. Do we need data here?
I think that's covered in.
Across?
No, I think it's covered in the separate proposal. I don't think this one covers any of the scalars.
I guess we had discussion in this chat about scalar version of pairwise instructions.
Oh, that might be
That's
because
why
it's
email got-
ARM64 only, so it's further down.
That's also a good plot.
I'm actually amazed that you can keep track of this. Like, there's only like what, 5,000 methods or something.
Okay, yeah, the scalar ones are further down, so we'll get to those. So these are just extract vector. I believe with
What does that mean?
It concatenates two vectors and then extracts a contiguous 64-bit block from it.
yes,
I don't know what that means. You concatenate them and then you do what?
You concatenate left and right, and then the index tells you which thing in the concatenated vector you slice out and treat as a new vector.
It's sort of like a rotate.
Yeah.
Oh, I see. Okay, that makes more sense now.
I'm not familiar with any SSE2 equivalent to this.
no, I don't think we have one. It's
The name seems...
for x86 we explicitly put the full vector type. So these might need to be vector 64 and vector 128 as the name.
I'll check that. I thought we only did the vector type when the returns were ambiguous.
Yes, and in some cases there can be, just from all the overloads, because this isn't the only type of extraction, vector extraction that exists.
Yeah, but it's the only one with this name and signature, right?
Right. But we've not had methods that differ based on vector versus vector 128 yet.
I see, okay. Not even store?
Not even which one?
Not even the store instructions?
No, the store consistently just store because the input allows it to be overloaded. Whereas extract, you can have multiple types of extraction where the difference is basically the return type.
So you're thinking there might be a scenario where I concat two vector 128s and extract a vector 64?
No, but there might be cases where, for example, you want to, you have a vector 128 and you want to extract a vector 64 vector concatenating. In which case, you couldn't just call that extract vector.
Yes, okay, sure.
So one quick question, so add pairwise is not generic, correct? So I probably should remove the generic instantiations from them, right?
What do you mean?
Yes.
Like the name has add pairwise off byte,
Oh yeah,
right? That
that's
makes
just a issue there.
I suppose that does not make sense. And then the next one, I suppose the last one is a typo because you say extract double, but then you only take floats. Not that it matters because the
Where? I don't see that.
Yeah.
extract vector, the
extract.
very last one. I mean, it's the same issue there.
Yeah.
technically, So we just remove the instantiations from.
Oh yeah, you're right. I'm looking at AVX. We do have extract vector 128. So yeah, giving this the same name would be consistent.
So the first one would already rename to extract vector 64 then, or
And extract vector 128.
Do the double and long ones for 128 belong on the advanced SIMD class, or do they belong under ARM64?
I believe they belong on this class.
Okay.
So you support long and U long, but no double.
Let me.
Long, U long, and double are all there for the 128-bit vectors, not for the 64-bit vectors.
Yeah, but like for the 64-bit vectors, we also don't support double, which seems odd.
Well, the 64 is because they're scalar types, effectively, when it's because they're 64 bits in a 64-bit vector. And so they don't always exist on every instruction.
Oh, I see what you're saying. Okay. Right. Sorry, you were asking what the 128?
So for some of the x86 instructions, we did actually name it extract vector 128, as Tanner said. I'm just looking through it right now.
Yeah, just renamed them here to extract
Yeah.
vector 64 and then extract vector 128.
Yeah.
I actually don't see any reason why double shouldn't exist for this type.
Well, vector 128 at least.
Yeah.
Well, it's float and double are intermixed there on the terms.
Yeah, I mean, okay, so then I would just add another one that just returns float, returns double and takes double.
Yeah. The only particular issue with that is that so functionally speaking, the index isn't an element index, it's a byte index, it looks like.
Uh-huh.
In which case you could tear a double and get a denormal value which would be normalized to 0.
Sure, we have done this in other places too, right? If you
Well,
do bullshit stuff.
x86 doesn't ever denormalize to 0, whereas ARM, depending on behavior, does.
Sure, but you can do crazy shit with like floating point numbers with like bit masking, where you said, well, if you give them a bit mask that does not correspond to actual sensible stuff, then you might get shitty outputs, right?
Okay.
So was the conversation there that that parameter should be renamed byte index rather than just straight up index?
Yeah, I think index to me would imply the element, which is not what we mean here, right? So we probably should rename
Right. At least if I'm reading this correctly.
Yeah,
Yeah.
I think that's correct.
Okay, then yeah, I agree with renaming it to byte index.
that. Okay, so then
Oh yeah, index is the lowest numbered byte element to be extracted.
so byte index then.
Yeah.
All right, byte index it is.
So I have a question about the instruction. It looks like takes the lowest elements from the second source and the highest elements from the first source, and it seems like the explanation in the comment is the reverse.
It concats the BMVN. So it concats high and low into one contiguous buffer.
Right.
And then it extracts a 64 or 128 byte sequence from that.
Right. But from the instruction itself defines that the high part of the concatenation is the second source, and the low part of the concatenation is the first source, which is
I
a
think
little odd.
I-
This makes maybe more sense,
Yeah,
but
I-
it might be confusing if you knew the instruction and then you're generating this. Just a
Yeah. I think
Weapon.
I think it might just I think it would end up making more sense to have it here and maybe explicitly name them high-low
yeah, that could be.
or upper-lower is the term we use in other places too.
So which one would you name?
So
it?
instead of left and right, we should call them upper-lower or high-low, because otherwise the order of the parameters here doesn't match with the encoding order that you would write in assembly.
Let's see. Preferences for upper or high?
We use both, so
Big one.
I think upper lower makes more sense here.
Okay. Then
I think we
upper.
typically use high for when it's part of the destination.
So upper, lower.
Mhm.
So upper is left and lower is right.
Yeah.
Well, the spec uses lowest and highest. So,
Yeah, the spec uses that, but for like we have a get upper and get lower as the general purpose instructions or methods.
Right, that works for me.
So I also, for this next one, I also called it out at the bottom. This should probably be max number, not max numeric. Number is the term used by the IEEE spec, which is what this is implementing, and I believe it's also the term used by the actual instruction. Yeah, the instruction uses number as the term.
And these ones we don't name 64, 128. We just use
Right.
overloading. Okay.
Because this one can be purely distinguished by the parameters being passed in.
Good idea.
So this is functionally implementing that that API we keep bringing back and pushing back because we don't know if we want to expose it on system math or not.
Yeah.
And this is for each pairwise element, return a vector that has the lower of the two?
No, we're looking at max numeric.
I was looking at min instead of max, but
Yeah.
so
But it basically, rather than propagating the nan, it returns the other value. So with normal max, if one input is nan and the other is a actual value, it returns nan. With this one, it returns the value rather than the nan.
Yep.
and we only need floats on that one. We don't need doubles.
The double form is ARM64 specific, so it's going to be lower.
Even for vector 128?
Mm-hmm. ARM32 is missing double support for a number of instructions.
But it seems like it's inconsistent in what instructions. Okay.
So generally, you'll have it if it treats the instruction as just a bit pattern, as the above.
Okay. Oh, so like the extract instruction, for instance, it's just treating it as blind bits and then shifting it out.
Yeah.
Okay. That makes sense.
Alright, so before we go to max pairwise, let's maybe remove the min numeric one first, because it seems to be the...
Yeah, it's the same.
So it probably should be min number then, right?
Yeah.
Alright, so then max pairwise.
Max and min pairwise just does the max operation, but on pairs of elements rather than elements across two vectors.
And we only support vector 64 here, no vector 128.
I think add pairwise only supported 64 when we reviewed it earlier.
Add pairwise, yes, that is correct. Did not have 128 either.
Right. And so the difference between max pairwise float and max number float is the nan.
Yeah.
Okay.
Max. Let's have precision. No, max pairwise should also have vector 128 here.
Should add pairwise as well.
F. could just find what the ARM32 name is. If I can.
Okay, I just added a comment so we don't forget about it.
So for max number, do you need a scalar version of those?
Those are lower. They're ARM32 or ARM64 specific, I think.
Man, the scroll bar is frustrating. I can't stop staring at it.
We've made no progress.
We've made progress.
I mean, there's like a centimeter of progress, exactly. But if we keep going at that pace, you might need formal meetings to get to the middle.
I mean, you could always schedule a bunch of one-off meetings.
I could.
It's just finding time for everyone.
Actually, we just go through because, I mean, I don't think we add a lot of value if we literally wait for this. I just added the comment for the 128 and then can trace it up offline.
Alright,
So I
then
guess,
min numeric becomes min number.
Yep.
yeah, that one already fixed. And then min pairwise, same comment for the 128 forms, right?
Yeah.
Yeah. I finally found the instruction. They have different names between ARM32 and ARM64, so it takes a minute.
Should give you max and then like.
Oh, I was looking at Pairwise one, because it's VP add rather than V add P. No, it looks like ARM32 only supports vector64 for the pairwise.
So you're saying what we
Pairwise
have
add or-
currently is
or
correct.
Also pair, or both pairwises.
For add, let me find the max.
Yeah, probably just makes sense emo to on max pairwise and then pairwise say check if vector 128 is needed.
Yeah, I just added this as a generic
Okay,
comment.
no, it looks like it's it looks like for VP max, it's also only for vector64 for ARM32. It's if size is 1, then undefined.
Alright, so then, what do we write? So, min number, min pairwise. Alright, so then, this one we probably want to rename the accumulator again to,
Abend.
Yeah. And these ones explicitly don't have float because they're integer multiply add, where fusing doesn't matter.
Okay.
Well, ARM32 supports floats.
Yes, but float has to have a different name because it's a fused multiply add, which is different from a multiply add.
Yeah, but on ARM32 it's no fused version.
Right, which is also why they're not here, but I was just calling out that the reason there's only the integer types is because
by design, yeah.
So there is multiply subtract. Shall we call it accumulator?
multiply subtracts a couple lines down.
Yeah.
Okay, now I'm confused.
Confused about.
What is the difference between this and this?
The one at the bottom takes each element of the middle vector, multiplies it by the scalar on the right, and then adds it to the addend on the left.
Yeah, scalar.
Right, which
Oh,
I-
these are scalar forms,
Yeah.
that's why. Oh, got it, okay.
no, I don't think it's quite scalar form. It's
That's what the comment says.
well, I think that's an issue with the API and is one of the things.
Yeah, it was originally proposed in scalar, but there is a version that accepts a vector and index of element in this vector.
Right, and so that should actually be a vector with a byte index into that vector.
You mean the parameter on the right?
Mm-hmm.
Yeah. Right should be vector right with an index for right index.
So basically, instead of taking 3 arguments, you want to take 4.
Yeah.
Mm-hmm.
And then right would be the same as left, and then you would have a byte index.
Yeah, which says which one from right do you want to use for the multiplication.
So right byte index.
Yeah. It's particularly
Byte.
useful for if you have a set of constants you're going to be multiplying by, and you don't want to have to trash a bunch of registers.
Is it byte index or element index?
I think so.
It's a byte, which is an element index.
Okay, so the parameter name is element index.
Yeah. So just right index.
Yeah, right.
Right index. Okay. Yes.
So in the name of the intrinsic should be multiply add or multiplied by element.
Yeah. Then I don't know about the name. It is doing a multiplication by a given element.
Okay.
But the overload should hopefully make that clear that it's...
Yeah, just having it as an overload on multiply add seems okay.
Yeah, so that should be right index, not byte index.
In the spec is called
Sorry.
Yeah.
All right.
So I think the original, so the specification there is is missing the discussion we had about last time, since that particular form was there for the convenience, since more often people would like to use just a scalar value, but that's a discussion we had below.
Which is that for the other overloads so far, we've said that the JIT can optimize vector create correctly.
Mm-hmm.
And just inline it so it's a singular instruction.
So this is actually, so what is this, multiply by scalar and then add? Is that what you had just said? Where the scalar is chosen based...
From the vector, yes.
I almost want to name this multiply scalar add then.
Well,
Because it's not doing element-wise multiplication, it's doing a scalar multiplication.
No. So it does per element from left,
Yes.
multiply by a scalar from right.
Yes.
Which isn't a true scalar, which we've typically used to mean it's the 0th index. It's a given element from right.
Yes. I'm like...
And then add that per element, add the result per element to the addend. So it's still doing vector multiply add overall. It's just one of them happens to be a scalar value rather than element-wise from the rest.
Sorry, are you multiplying each element of left by each element of right and then choosing a result from that
No,
product?
it's you multiply it's for each element in left,
Yes.
multiply by right index,
Yes.
and
okay.
then add to the corresponding element
In addend.
in addend.
Yes. Okay. That's why I had gravitated toward multiply scalar add, because you're multiplying each element in left by mathematically a scalar.
Yeah, but concept-wise, as we've
Sure.
exposed it, I think that might be confusing.
Okay.
Since scalar is typically meant
Sure.
0th element
No, that's fair.
from the vector.
And there is value in having consistency.
You can call it by element, the same as called in spec.
Well, they're all by element, which is the confusing bit. It's doing a by element operation.
It's probably okay, and just hope that nobody accidentally hits this overload unless they intend to.
Yeah. I mean, I can see both arguments, but
Because I mean, if you've hit this overload, you've probably hit F1 in the IDE and been like, what on earth is this right index parameter? And then either realized, yes, this is what I wanted, or hold up, let me backspace and remove that fork parameter.
Yeah.
I mean,
Is it weird to have two overloads for the? Sorry, I guess the instruction is the same name,
right.
so it actually is overloaded.
Yeah.
I mean, honestly, overloading by arity usually is not that bad because it's pretty obvious in IntelliSense. What really fucks with people if you have very subtle differences in types. Because then it's like, well, you have to really read the documentation on what this thing does. In this case, it's like, well, it tells you that it takes a byte, another index, which you would have to pass in somehow, right? And like that seems not something you would accidentally do.
Maybe, but it does but then that sort of suggests that the one that's missing that parameter does it at index 0. So if we have one that takes add in left and right, and then one that takes add in left and right in the index, and it behaves differently, I think they need different names.
I wouldn't even say that that's the case, because we have plenty of examples where if you take another parameter, then it's very different behavior from just assuming it's 0.
Not a whole lot. Usually it's that it's null or 0 or some other sensible default value, not that it's a different algorithm.
Yeah, we can't default this parameter, that's the thing.
Well, I wouldn't default it anyway, but I would say that.
No, but I think what Jeremy was arguing is if we can't default this parameter, then logically it shouldn't be an overload of a
I know, I got
short
that.
circuit.
I'm saying is that, for some reason I can't think of an example, but logically what I was thinking of was something like it's basically unbounded, so you can't express it as a static value, but it just means you get different behavior, right? And that I don't think is very different from what we have here. Because you take the whole vector rather than a specific element of it.
Right, and so
But-
you can't explain, like, this one and the other one can't be explained in terms of each other. They're fundamentally
Yeah.
different. And so to me, they should be different method groups.
Yeah, I don't know if we have a good name that clearly defines that, though.
How about multiply, add, select scalar? It's kind of what's happening in the right side.
Because really the problem is when somebody finds this and they hit F1, they're going to assume that all of the same thing with the same name is going to behave the same. It's the complexity of like, no, when looking in the documentation, like realizing that between here and here it was actually a very different thing, even though the name didn't change.
Yeah, the one thing that is true is when you look at our docs right now, like what Jeremy said, I think is very true, because you have all the overloads on a singular doc page.
Yeah.
And then you have to manually find the one, and then if the
Yeah.
summary is drastically different between A and B, then you wouldn't necessarily see that.
So I don't think select scalar would quite work, but maybe if we inserted by in the middle there, so multiply, add, by, select scalar
Yeah.
would work.
Sure.
Just from, I think select scalar would indicate, like, if you select 4, it does only the 4th and leaves everything else the same.
Yeah.
So, but I
Maybe it
think,
should be selected instead of select, but yeah.
yeah, multiply, add by selected scalar or index scalar or something.
Yeah, that's quite a mouthful, but yeah.
Yeah.
What about multiply, add by scalar index?
Or if the other one's just multiply add, then multiply add by scalar is at least enough to, like, you've broken them into two method groups, and now you can at least explain this one picks a scalar out of the index and this one is pairwise multiplication.
I think that might be reasonable.
What about by element? Because
By element or by index would make this a little shorter to type.
yeah.
A by element, I think, is confusing because normal vector operations are by element. Like when you do add, it's by element addition.
Fair enough.
What about by index?
But index element.
Yeah.
Yeah, this
That-
seems
Yeah.
reasonable.
Okay, then let's take this name and like call it a day. So we actually make some progress here. Because eventually I would like to scroll.
Not today.
Did anyone on YouTube have any comments?
There were comments, but yeah. Let's just say I had some streaming issues. All right, so multiply, subtract.
Yeah, so same thing, regular and then by element or selected index,
Okay.
selected scalar, whatever we decided.
So we don't want to call it addend anymore.
No, we don't want to call it. How do we call it? Subtrahend.
Well,
Subtrahend seems to be the number or the name of the thing that you were subtracting from something else.
would it
Is that legal English?
is
yeah.
is addend
It's not
technically
subtrahend,
wrong when we actually
it
have it
numerant?
as subtract the addend?
It's not the subtrahend.
Because we're not negating it. We're literally doing minus
Yeah.
a number as given. So if you give us a negative number, we're going to invert it, and it's
Yeah.
effectively still an addend.
It is the minuend.
Oh, this is what to subtract from, not what to
Yes.
subtract
Yeah.
later.
So I think
Okay.
addend
So yes,
might.
minuend is the
It's the minuend or just accumulate.
Okay, minuend. So that is minuend.
Yep. So
This is terrible.
mathematically speaking, the number is the minuend. It is the number that you were subtracting from.
Obviously.
no one's going to understand this.
Indeed.
Well, let's.
But obviously minuend is related to the subtractee half, and then you look up the form. Like, you're not going to remember which one it is, but the order matters. But what really the important thing is we use a word that makes it clear that it's related to the subtractee part instead of the multiplying part.
Yeah.
Or we just call it X, because clearly find X is always the correct answer.
Leftier. It's the thing that's more left than left.
Can I just call the accumulator?
Left of left.
Yes.
Left of left, left right. All right. So looking at the same thing, right? No float versions. That's by design, right?
Yeah.
And then the bottom side we just renamed to multiply, subtract by selected scalar.
Yeah.
Yes.
I really feel it today. This is crispy. And then of course, it's called right index.
Just wait, Emma. We've not even gotten to, and I don't think we're going to get to the really good names.
Yeah.
The really good names.
So I'm seeing the scroll bar like go down ever so slightly, the slider, and I kind of want to just write on the wall that's being projected on, just like, you know how when you have a kid you like
You
put little ticks
like
on the wall as they
11 and
grow. Yeah. So it's like 6 months, 12 months, 14 months, and then we can see progress being made here.
I think part of the problem is that this API proposal is in the issue twice.
Yes.
So it's really twice as long as it should be.
And then after 18 years, we send the proposal off to college and get approved.
All right, I think I did the right thing, but let me double check with Notepad again. And by Notepad, I mean Sublime. So this is it, right?
Yeah, except not ACC.
Yeah, that's yes. Actually, that's also true. If you would have given me the right APIs, then you wouldn't have had this conversation.
If only I could predict all the names in advance.
All right. Then fused multiply add.
Yes. So same thing as multiply add, except with floats, and so it does a fused operation, which means that there's no rounding in between the multiplication and the addition.
Okay, so we call this addend.
So one question that came up was that for fused multiply add in particular, and I guess to some extension multiply subtract, the math API and the x86 API is A times B plus C, whereas this is B times C plus A. So it's so the first parameter is the addend rather than the last parameter.
But that's what we had in the other ones as well.
But not for x86 or the general purpose math fuse multiply add.
Gotcha.
I'm generally for leaving it to match what the instruction does, but it might cause some confusion when people are porting APIs. So I thought I'd explicitly call it out.
Yeah, I mean, like, well, I think that the names need to match .NET semantics. The making the parameter orders be correct and not doing like JIT twists and other weird things of that nature seems like you're programming against the ISA. The name is going to help you say like one of the we have left, right, and the other one, and that tells you which one is special.
So one thing that we could do to assist here is we could also imagine having a like a code analyzer that says, hey, you are within the same method calling x86 FMA and ARM FMA, and you're passing the parameters in differently in both places. Like you can imagine that could be something to help developers see that they have a problem. I'm spitballing here, but
Yeah.
if they use named parameters, as I would probably do if I were coding against this, like it won't be an issue.
Really, you would use name parameter calling convention?
Oh yeah, for something like this.
For fuse multiply add in math, it's great because I think they're just XYZ.
Yeah. I would absolutely use name parameters here.
I mean, then you really.
I mean, we
spend
have
lines.
we
lines
have
is good.
3 parameters that all take the same type. Like that's clearly a case for name parameters.
I think I only ever do it with bools.
Yeah. And hell, I opened up a PR a few days ago where I used name parameters to mem move, mainly because I can't ever remember the order of parameters because it's all just void star everywhere.
Well, it's clearly there's only one correct answer, right?
I would probably use the name parameter for the odd one out,
Sure.
and then let the other two be like, yeah, the order of these doesn't matter, and you know which ones they are. When it's divide, you need to know which one's actually the one on the right.
So are divide going to be called left to right, top bottom, quotient dividend, or whatever the thing about is?
On the one hand, we have a guideline that suggests naming them quotient and dividend. On the other hand, the last time I brought that up, everyone looked at me like I was the devil. So
The downside is in 5 days, I'm proctoring
Which I
like
agree.
a math competition, so I should know these terms.
You should. No, honestly, for binary operator, like left right makes the most sense. Once you have more than left and right, yeah, then you need to specify where shit goes. But
it's like math.divrim, where I constantly have to go look up which thing is it outing and which thing is it returning.
Yeah. For ternaries, I agree, because that becomes no longer expressible on a piece of paper. All right, so then multiply. So fuse, multiply, add, fuse, multiply, subtract. We just call it minuend, left, right. Order remains the same as written out here, right? We're not
Yes.
swapping shit around.
Yes. I'm sending you this for the next one because I know it's going to come up.
All right. God, even the scroll bar in my document is not going any further. Polynomial multiply.
Yeah, so just open the image I sent you and share it on the screen. And that will explain what a polynomial multiplication is. It's basically over 0, 1 as a string of bits. So it's not quite the same as regular integer multiplication.
I guess in some question,
Hold on.
does it actually matter? Or are you worried someone's going to
I-
want a different name or?
Generally, when something's been complex like this, we've shared
How do I do
what the term means,
Okay.
just to give everyone make sure everyone's on the same page, at least somewhat.
Okay.
I don't think there's any better name or anything else, but we generally just roughly share the concepts so people can understand. So this describes how the inputs are interpreted and how they are functionally done together.
We've entered the Galois field.
Polynomial multiplication. So just briefly sharing what polynomial arithmetic is, and then hopefully no one cares about the name.
I mean, you take a left and a right, and then
You basically do bitwise arithmetic as per
Yeah.
what's said here.
This is pretty common
Sure.
in cryptography.
That's why it says it's in the cryptography extensions.
Yeah.
cool. That was interesting. And then we only have byte and s byte.
Yes,
you do
because it's function. It doesn't necessarily make sense over the longer types.
And they can all be converted down to the.
Right. You just do .as type.
Yeah.
Or .as byte rather.
Because it's operating on bits. It's not
Bits,
operating on
effectively.
ints. So
We
bytes is the smallest addressable thing that we can talk
we
about.
could expose the other ones for convenience, but I don't think that's necessary, especially in the common use case for these types of instructions.
Yeah. I mean, I'm just asking
Yeah.
the question. I'm not having
If
any
people
opinion.
if people do ask for it later, we can always add it.
Reciprocal estimate. That's probably some super cool thing. It
Where-
gives you back a number. It's cool.
Oh yeah. So reciprocal estimate does it's basically a fast way to compute 1 over x without compute, and it introduces some margin of error. Division's expensive. This does it faster, just with a minimal amount of error introduced.
Used for games primarily? Okay.
Or other places where fast arithmetic is wanted and acceptable.
And it's element-wise 1 over x.
Yes.
For polynomial multiplying, does any of the x86 based ISAs have a similar thing? Because if we, really my point would just be if we added vector 64 event to the x86 ones, especially because I assume it's all going to be the same exact instruction in the end and no type encoding, we should be as consistent with the overloads here as that one. So if we added convenience wrappers from int and long and stuff there, we should do it here, and if we didn't there, we shouldn't here.
Like pickle muckle duck might be the closest thing on x86. Yes, there's an actual instruction called that.
Yes, if we have polynomial multiply in both cases and we added convenience in one, we should do it in the other. If someone asks for it later and we add it to one, then we should add it to the other.
Yeah, I don't think there's an equivalent.
Okay.
Pickle muckle deck is carryless multiply, which isn't quite the same.
Okay.
Yeah, it's a roughly analogous, but
All right.
Right. So then, I was gonna say I feel like reciprocal estimate should really be estimate reciprocal of like verb in object order, but I don't care.
So there is a SSE dots.
We have not done this before, right? Polynomial multiply. Fuse, multiply, add, right? Like we have this across the board now that the verbs are in weird places.
Right. And then it'll make more sense with reciprocal step, presumably. That reciprocal is the thing you're looking for, and then which kind of reciprocal. So a common prefix.
Notably for x86, we just called it reciprocal because the instruction doesn't have estimate in the name. And
is
that's
it an estimate?
It is an estimate. There's like a 0.12 ULP or something like that. 1.2 ULP error.
Then maybe we just match the name then and call it reciprocal. Is there an actual 1 over x exact instruction?
Divide.
You have to get a vector of 1 before you call that though, right?
Right.
There's no instruction for don't take a left vector, just reciprocate everything in here.
I don't think so.
Okay.
At least I don't see one called FR CEP or ECP.
On x86, do we also have the other reciprocal types?
There is no step, but there is a square root one, reciprocal square root.
And so we have reciprocal and reciprocal square root for x86?
Yeah.
If we already didn't use estimate to make it not feel like a stem, then I would match the terms across the two if they're, as long as they are functionally equivalent, like that they're both producing non-exact answers, then I think the reciprocal is fine on both. But I can go either way.
So the instruction in the ARM manual specifically is reciprocal estimate. Right?
Yeah.
I mean, it seems unfair to bias the ARM instructions against what we previously decided for Intel.
And if there is in the future some exact instruction for x86, we'd have to call it like square root exact or something, or reciprocal exact.
Right.
If we think that this is easier to understand, that we have an estimate and an exact instruction, assuming one comes up in the future, then I like this name.
Yeah.
And we just say, well, we learned from when we did the x86 instructions.
I mean, there's an argument for consistency between them, but the only thing I would say is like it would be very impossible to align Intel and ARM in general. So I wouldn't even try, because if you try to make things more consistent than you actually can, you actually do a disservice, I think.
Right.
I think it's more important that ARM within itself is self-consistent, because that's the only thing you can tell people or explain people.
It does not specify the maximum error from what I see.
So then we said the name as proposed is fine then?
Yeah, I think that's what we just agreed.
Yeah, it seems good.
And then again, like it's float versions across, right?
Yes.
And the index is an element index, or is it still a byte index?
You already moved on to reciprocal step?
Okay.
Sorry.
Yeah, I think so. I missed that move
So-
too.
Yeah.
I tried to scroll. I tried to push further. Yeah.
So it's a reciprocal step. It still ultimately produces an estimate on the first step, and it slowly becomes more accurate the more steps you do. And I believe the index is the step count that you are doing. So it's not an index or anything else. It's just the.
So maybe it should just be called step.
Yeah.
Well, you definitely want reciprocal somewhere in the name because it's
Well,
part
I
of the
think we're
reciprocal.
talking about the parameter.
Yeah.
Talking about the in
Oh,
the method
parameter,
group's
sure.
reciprocal
Sure.
step, the final parameter, which is currently named index, is not indexing into left or into right. If it is the step, the number of steps or the step number you think you're on, then I would call it step.
What are left and right here?
The first two parameters.
Is one the original value you're trying to compute the reciprocal of, and one the intermediate value after the step function?
Let me figure that out.
You were asking all the complicated questions.
I'm like,
Yeah, I literally have no idea what a reciprocal step is going to do and why it would take more arguments than reciprocal other than the step. Also, I don't know what a step means. So. But index. Index is a word I understand.
Actually, why is there an index
There
here?
should be an index.
Yeah, the
Copy paste error.
Tamar, do you know why? I think you were the one that wrote up this particular proposal.
No, I'm just looking myself.
Okay.
The instruction only has 3.
Right.
I feel slightly less dumb now. It's good. Oh boy.
And I think that looks like indeed a copy paste error.
So, what it does is it multiplies the corresponding floating point values in the two sources, subtracts each of the products from 2, and places the floating point value in a vector. So if you were going off of a stepping algorithm, then one of them would continue to change.
Seems.
Yeah. We could probably have better names than left and right here. But I'd have to look at probably the Taylor series for this and figure out what the term to use would be and which one corresponds to what.
So should we just hold off on that one then?
Yeah, let me just add a comment on this and then shows the
Confused.
So if you look into the implementation of this algorithm, just multiply left and right and sum them to
Yeah, and then adds 2. And I don't know the particular series off the top of my head for stepping to know which terms would be the right ones to use here.
So here's another question from, okay, let's finish the reciprocal ones, and then my question would be, should we continue this one because we will definitely take the full 30 minutes and not finish this, or should we look on the other one and finish the other one? I'm not sure that helps your case or not. But we will definitely have to have another meeting to finish this one, no matter what we do.
Well, so other than the other step one, there's just reverse element bits left in this one, and then we can move to the next one.
Or to just finish everything before ARM32, is that what you're saying? Because the other things are all ARM30, no, never mind, there's ARM64 as well. I
Yeah,
guess.
because the ARM32 ones, I think we can basically skip because we're not going to be implementing these for 5.0s. We should just say we should come back to them in a future issue.
Okay.
And then the ARM64, it's basically everything we've already reviewed, just with the ARM64 specific overloads. There's no new instructions other than reverse element fits.
Well, except the growth.
No, so they are the reduction ones are on 64 only.
Okay, yeah, I see those. There's a cross added,
All right, then let's.
but there's not very many left. I think we could finish this one.
And those
Okay.
are the names that were contentious, right? The
Yes.
cross ones.
For scalar,
Pairwise scalar.
Because-
growth is a
Oh,
growth.
then that's a different issue.
well, it's still this issue.
Okay.
But yeah, we can just, that one, that particular issue needs to be discussed, so.
All right. So then, let's finish this one. Okay. So, square root estimate.
Yeah, so it's the same thing except it does a reciprocal square root instead of just a reciprocal, and then it estimates.
Seems reasonable.
It's weird that it's reciprocal square root, because the description says it just calculates the square root, but sure. I agree that the instruction says it's floating point reciprocal square root estimate, but their description to me just sounds like it's square root estimate.
Even though it says reciprocal square root estimate there?
Yeah, I was reading the instruction architecture to find out what this instruction does, and it says calculates an approximate square root. I'm like, then why is the word reciprocal in this name? But it is in their manual, so.
Are you sure you're not looking at F,
I'm looking at FR Squirty.
okay, because I think it's also F squirty, which is different.
So this is 1 over root?
No, it says reciprocal square root estimate in the manual here.
Yeah.
Oh.
The instruction says the name is floating point reciprocal square root estimate. Then the next sentence, this instruction calculates an approximate square root.
Yeah, I see.
So I don't understand where the word reciprocal comes from.
Possibly 1 over square root then? Might just be a typo in the manual.
Yeah, I think so.
All right. So then, you happy with that name?
Yeah, that matches what we've got on x86 other than
And then the next one again is reciprocal square root estimate that takes left, right, and index.
yeah, that should be called step rather than estimate on the next one. And it's going to hit the same issue as reciprocal step.
That's what I thought. So then we remove the byte index,
Yeah.
And then
we should
see
figure
if we
out.
can come up with names for left and right, but
Yeah.
they may just be left and right.
We can't see what you scrolled to.
Yeah, I know because this is my editor, which is. Let me actually go back to where I
And then,
was.
out of curiosity, Tanner, what do we do on any of these when the floating point exceptions of any forms are raised? Do these throw?
The JIT does not support floating point exceptions being enabled on the hardware level. If you do, it's undefined behavior.
So not a number? You
It's
get that
undefined
mode.
behavior.
No. I mean, if in the standard state of things where we're in a fully supported environment, is the result not a number when you try doing like division by 0?
I don't know what ARM does in that.
Okay.
Okay.
Because I was like,
Yeah.
just this instruction can generate a floating point exception.
Yeah.
So then I'm just curious what happens when that if can means sometimes doesn't, or sorry, it means if you've turned off exceptions won't, as opposed to
Right.
can means depending on the inputs it might.
Yeah, I think it says like following that sentence, depending on the behavior of FX, CSR, or whatever.
Right. Well, it says it results in either a flag or a synchronous exception being generated. And I didn't know if we were checking the flags and if we throw or.
Yeah, the runtime just doesn't support them today at all.
But we're just pushing things in and letting the CPU do what it does.
So cool.
Okay.
There's also typo index should be there
Which one should be there?
for estimate. Left, right, index parameters.
Yeah, we already fixed it to step, reciprocal square root step, and then remove the last
Reciprocal
one.
square root estimate of the phases.
Yeah, that one should be called step.
All right, then reverse element bytes. I guess it does what it does.
Yeah, it does it just reverses the byte order.
Seems reasonable.
We call this reverse endian in some other APIs.
Is this the same as the R bit or different, Tamar?
It's different. The R bit just replaces just reverses the bit balance.
Okay, so this one is reverse Indian rather than reverse bit, and it's the vector form.
Yeah. Right.
Let me double check that. Yeah, so on binary primitives, we have reverse endianness as the API name. And it takes everything except for float. Because I don't quite know what it means for float. Treated as the same as int.
So Jan said we shouldn't expose float because some platforms will normalize float to 0 if it's a denormalized float. Or they may normalize nan to a consistent nan if it's a nan. So it may not necessarily be swap bytes. It could potentially be swap bytes and change the value subtly.
So I guess my question would be then, at the processor level, is this operation actually defined over a vector of floating point, or does the processor in practice just treat it as bytes and then swap them all?
I believe this is over integer types.
Alright,
So should we remove float?
Probably.
Okay, then let's do that.
And if someone really wants to use it, they can
Toss it
as
themselves.
bytes.
cast.
And are U long and long supposed to be here even on the 32-bit ISA? Because it's being treated as an actual element of 64-bit width.
Let me see if I can find the name for ARM32. It's got a completely different name. I don't think I'm going to be able to find this easily unless someone else knows the name.
Yeah, it's called, so on ARM it's VREV, and then the numbers of VREV 16, VREV 32, etc.
Great.
Oh, okay. There we go. So
So Vir, you're right, there is the 64-bit one shouldn't be there for ARM.
So long and U long?
Yeah.
Alright.
and we should move them down to ARM64.
And remove the floats, it sounds like.
Yeah.
So these are the floats, and then the reverse element bytes with U long and long you want to move to ARM64.
Yep.
Yeah, let me do that.
Did we want to keep reverse element bytes or leave it reverse endianness?
That I don't really feel too strongly about.
I think that reverse element bytes or reverse element endianness might be more clear in this case. Just to differentiate it from interpreting it as a singular 128-bit vector.
Yeah. So given that they call it in the manual reverse bytes, and we're adding the word element to help you understand what it's doing, reverse element bytes seems fine.
Oh, it looks like
Oh no.
it's called reverse elements, not reverse bytes.
So I'm looking.
Not the 64.
Please correct me here, but I'm looking for the actual manual, and it looks like you can also reverse not just bytes, but you can reverse words within elements, and you can reverse D words within keyword elements, stuff like that.
Yes, that looks to be the case.
Rev 16 vector
Okay.
does say reverse elements, but elements isn't capital. Okay.
So do we also want here reverse element words, reverse element D words? What?
The actual instructions allow you to reverse bytes.
Words and D words.
Mm-hmm.
So reverse element word would only be defined on vector int or larger, and reverse element d word would only be defined on vector of long,
Oh, no.
assuming we wanted to add
Those look like ARM32 only. Were you looking at Rev32 or VRev32?
I'm looking at VRev 32.
Yeah, Rev32 doesn't support the other operation, looks like.
Right, but we're talking VRev though, right? Not Rev?
Well, this is the one for both.
Is there a vectorized Rev 32 that's not VRev 32?
Yeah, it's just Rev32 for
So there-
ARM64. The ARM64 and ARM32 have equivalent functionality but different names.
Okay. got
But
it.
but the ARM64 version does not support the other part that you were discussing.
Okay. Okay. So this actually is Rev 32, not VRev 32. Right.
Right.
Well,
'Cause, like
it's-
ARM 30 or ARM 64 has like Rev 16 and Rev 16 vector.
Yeah. Okay.
Are the names at least in
Like I clearly
Whatever
don't know what
manual I have to have
I'm
open.
talking about.
ARM32, this will emit VRev.
But what about the ARM64 specific functionality of swapping 16-bit?
No, that's ARM32 only, is what we were just saying.
It looks like Rev64 and Rev32 vector
It's supported now, 64 as well.
do support that.
Yeah.
Am I on the wrong overload?
Yeah, so I'm just wondering if indeed we should split these up to just individual intrinsics for each instruction.
Hmm.
yeah, like reverse element bytes 16, reverse element bytes 32, and reverse element bytes 64.
Yeah, I don't. Could you?
I feel lost.
Where are you seeing that it supports the?
So the general implementation of
Oh,
this is that you go through a vector, you get each 32-bit integer from within the vector, and then you just flip the order of the bytes for
I
each
see.
element.
Okay.
There is an additional mode of operation where you go through the vector, you pull out each int, you divide the int into a high 16-bit int and a low 16-bit int, you swap those, and then you write the thing back to the destination.
So maybe I would suggest that we need to think about this one more and bring it back
I like
instead
that.
of design it
Yeah.
On the fly?
in this meeting.
Yeah,
I
it's
like
basically
it.
it's a rotation operation instead of a
Alright.
byte swap, what I just described.
Yeah, a couple of links in the ARM manual looked to be wrong, and I clicked the vector one, and it took me to the scalar one for ARM64.
Ah,
Sometimes.
Yeah.
so it seems like maybe there's more flexibility than
Yeah.
is spec right here.
Yeah.
Yeah, I think the proposal would be pretty simple, but we
Right,
should do
right.
it separately.
Alright, then let me remove them. And I will also delete the one from 64 for now because it seems like we need to remove the whole thing. So, alright, so now my next question is there's now an ARM 32-bit.
So ARM32 we can probably ignore for now because they won't be implemented for 5.0 anyways.
Okay, so then let me remove this whole thing literally so we make it clear what we actually reviewed. Alright, deleted. Alright. Somebody in the chat says, computers are hard, aren't they? That is certainly a true statement.
Only a lot.
But I guess that's why they pay us the big bucks. Although sometimes I feel
You
like the
get
bucks
paid.
aren't.
This isn't a volunteer effort.
No, I get paid. You guys volunteer.
That's how it goes.
Because I'm the one streaming.
We're unpaid squires.
It's called YouTube monetization. It's like I get rich from the 64 views we get. Alright, so I'm 64. So I ignore that it's supported because it's standard boilerplate.
Yeah. So basically, these first ones are the same things we've already reviewed, but the ARM64 specific versions, specifically on doubles, and then add pairwise. These ones are over vector 128. and then adding in long and u long here.
Yes. Okay.
Okay, so they're all double, and then the pairwise one.
What about int and uint? Do those need to be here too? It's all 10, right? For add pairwise?
Yes.
Okay.
It looks like they were just missed with
Sure.
long and u long were replaced with.
Okay, but you intend for it to be overall 10. Okay.
And T there in the best is just a typo.
Yeah, it's a placeholder.
Oh, lazy fucker.
Probably written as pseudo-generic
But-
before and then only got partial replaced because I mean we can't name a method add pairwise of byte.
Yeah, like, that's I fixed
I mean
that
I guess
one.
we can. Just it means that byte is now a T. So yeah.
All right, long, u long.
While Elo's typing that up, it would be nice if we would change perhaps vector of t to start using some of these under the covers when it's available.
Yeah, there need to be support for other bits as well. And there's potentially an issue with lots of inlining happening and hurting overall JIR throughput.
That's fair.
So that's it.
Take
int.
long and u long copy paste and add into uint.
Yeah.
But you have to make it look like a B when you do that.
Didn't we?
Yes.
Has to
Was
be
this
in the
one
right
we
order.
changed the upper and lower?
So what?
No, that was extract.
Extract.
Yeah.
So uint.
So between short and long, add overloads for int and uint. And if you add some there, it should retain the B shape.
But you made it bigger. I can read this without squinting. I mean my eyesight's fine.
Like, aren't you a pilot?
I'm good enough for I'm good enough for class 3 medical. I can't pass a class 2 unless I.
So in other words, you're not going to be a fighter pilot in this life.
No, my eye surgery overcorrected me from nearsighted to farsighted, so I can't be a fighter pilot.
All right, that's the one.
Yes.
I also aligned the visual layout so we can look at this without having a scotch in between. All right.
Yep.
Cool. I was about to say that was easy, but that would be a lie. So extract vector.
So this one adds double. It would potentially have the same concern over. What was the one we just got rid of? Reverse element bytes, where double could be extracted and then silently mutated due to it producing a NAND.
But I thought we just earlier said for float it's fine.
Yeah,
so-
and then when we got to reverse element bytes, we said no. It might be clearer
Fair
to
enough.
say for extract, don't expose, float, or double.
Yeah.
Users can convert, specifically because on ARM it might mutate.
All right, so then let me.
So this API goes away, and on the other ISA, extract vector of float, extract vector of float also goes away.
Yeah.
Okay.
And if you really need to do it over floats, vector 128 of float dot as
As you went and then
Yeah.
convert back.
yeah, fortunately. That way you at the call site are explicitly stating I intend for this to be bitewise.
Okay, so I added extract vector shouldn't have overloads for float and double. What was the rationale? Because it normalizes? Was that the idea? Or
It
was
could end up basically corrupting the floating point value. For regular integral types, like every pattern is valid, but for floating point types, patterns have semantic meaning,
Right.
and you can't just do arbitrary bit twiddling and expect sensible results in the end.
Fair enough. All right.
Is add across sum?
Yes. It across the vector adds them and computes the sum.
Can we call it sum?
I don't think so because there's other things that do across operations
Oh.
where
Okay.
Also, this should be returning a vector, and users need to call dot as scalar.
So it returns a vector where the 0th index element has a result and everything else is
Right.
undefined, 0? 0, okay.
What is defined? Just not the way you want it to. Alright, so they all return vector 64?
Yeah.
Sorry, except for the 128 one.
Yeah.
Is there no float or double equivalent? Oh, you don't have long and U long here. Never
yeah.
mind. Okay. Even float wouldn't be.
Well,
supported?
that's one of the discussions we had below, is because those are exposed as at pairwise scalar,
Okay.
since they implemented different instructions.
Doesn't add across return a vector?
Yeah,
Yeah,
that's what
yeah,
we were just
of
saying, is
course.
it should return a
Oh,
vector.
sorry.
Okay.
And they should all return vector 64 of the same type.
Even the
Even
ones that
one.
take 128?
I believe so.
Okay, then we need to rename them to add across 64 and add across 128.
Let me check.
Yeah, they should, because it's basically just the bottom lane that's being used.
No, it's still unambiguous.
Why would it be ambiguous? It's still,
Yeah, when did we get that? What was ambiguous in the previous?
I mean, it is differentiated by type, right? Like, you don't.
Yeah, in this case, it would be unambiguous because they're taking different types.
Yeah. I just remember something at the beginning was.
Yeah,
This
there's
was extract.
There's cases for extract where you're taking a 128 and returning a 128 or a 64 based on other parameters.
Okay.
Why does the 128 return a 64 vector?
Because on ARM, vector 64 is the smallest addressable vector size, and when we're talking about scalars, it's a vector 64 of that. It's similar on x86 where vector 128 is the smallest size, and so when you return a scalar, you return the lowest element or the lowest addressable vector size, because they're essentially extensions of one another.
So should I ask about saturating?
That's not.
Like, if people were using this at 128 and then would they expect to be able to pass the result on to a function taking a vector 128 and then have to do a conversion or something?
They might, but they'd be able to if they just do 2 vector 128.
I see.
They just have
no
to call
cost.
Yeah.
Conversion. Okay.
Is that going to give them 0 extend or
On ARM,
or
it's
whatever's there?
on
or-
ARM it's explicitly 0.
Okay.
So it's non-zero cost.
No, ARM inherently zeroes the upper.
Okay.
Alright.
Max numeric is max number.
Oh, that's right, yep. Good catch on that one.
Wasn't the common max pairwise just max pairwise? Oh, these are the because
This
these
is
are the
yeah.
Max-
Has
yeah.
special
these are
man
the
back
floating
on.
points. So it's max number pairwise.
Yeah.
And then max number across.
Yep.
And max number across would also return a vector.
64.
Yeah.
Yeah. I understand the formula. Only took 2 hours.
Alright, then max pairwise.
That seems okay. So float and double are supposed to be there.
Why do? Oh, that's because the common only defined it for vector 64, right?
For which one?
Max pairwise.
Yeah.
Do we not need long and U long?
Let me check if they're missing.
Seems odd.
S max P.
I mean, that's probably just us being nitpicky because I imagine when they're implemented, at the time of implementation, we would just double check and make sure all the types are there.
No, long is not supported.
Really?
Yep.
Okay, who's supporting long then? Nobody?
Nobody.
Oh, is it because they don't want an intermediate 128-bit type to hold the result?
But you took a vector of 128 and you're writing to a vector of 128. Well, it seems like it should be doable at long. Just
It might be because it's technically max across in that case.
Oh yeah, because there is max across for long and long, but
Yeah.
So why is that max across?
but max.
Yeah, I guess the difference is you end up doing 2 max across instructions if you want to score long.
Right. Well, because max pairwise vector 128 long is just you're doing two
2
two
acrosses. It's 2 acrosses. So you cross across and then you across the results of each.
But I thought pairwise was element 0 of left to element 0 of right.
No. So that's the normal operation for max, is element 0 of left, element 0 of right, etc. Pairwise is element 0 and 1 of left, element 1 and 2 of left, element 0 and 1 of right, element 2 and 3 of
Okay.
right. It does it in pairs rather than in single elements,
So then why are there left and right?
because it concatenates both.
Okay.
And then
It seems like it should be named upper lower again.
Yes. If there's something that we previously named upper and lower, we should name it here the same way.
Yeah.
But apparently, I can't keep all these instructions in my head. So.
Well, given how they are named by ARM, I don't think they can either. Like,
All right, and then all the max acrosses in this big block are returning vector 64 of big instead of thing.
Yes.
Okay.
all of them, including the 128 version.
Yes.
Okay, and then before we move to the next ones, let me find the discussion because I don't see the APIs that we're supposed to. They might have gotten dropped by accident. If you scroll down to just search for max numeric pairwise scalar. No, you're going to have to do a control F here.
What is it? Max?
Numeric. Pairwise scalar. Yeah. So here's where we weren't able to decide on a convention here. The issue is that there's a couple. So max numeric pairwise has a scalar version. Since it's scalar, and therefore it takes the same arguments but does a bit different behavior, we have to call it differently than just max numeric pairwise. Functionally, for float, it is a max numeric across. But when you count the half precision support that will have to be added in the future, you can't call it across because that's not how it functions. So the best name that I could come up with, and the name that matches the instruction, is pairwise scalar. But that is confusing to some people because a pairwise is not strictly speaking a scalar value.
No one understands it and it matches the instruction, ship it.
Yeah, I agree with that. I don't know what else you would do, honestly.
There's a difference between pairwise scalar and just pairwise operation. The pairwise scalar operates on one register.
Yeah.
But pairwise scalar operates on two registers, so it can count them together and does.
No, because pairwise is never across 2 registers like that. It's always, pairwise just means you take 2 consecutive elements and do the comparison rather than comparing across 2 vectors. And when you have 2 registers, you can concatenate them together into one big register.
Right.
But pairwise specifically is just comparing 2 neighboring elements.
Yes. And scalar version operates on one register.
On one pair is the best way that I can describe that.
Right. So, like, I'll just, if it is the name of the instruction, it may be confusing to people, but they're programming against an ISA. There's going to be a lot of
Max
go learn what
NP,
things mean.
I think.
kind of have to should we just use the regular instruction names now, not even on x86. Shouldn't just call the instruction pickle knuckle back.
Oh, Fmax P scalar.
Yeah, that one works too. Or no, it's F ac in M. If it's F max in MP. Because it's specifically the pairwise versions that have the naming issue.
Did I fuck this up? No, I fucked this up. I turned a bunch of mints into max. Not a biggie. Yeah. So, does it help you?
Yeah.
Where do these guys go?
Hmm? Oh,
Like,
they would go just. There's a few versions, and if we're saying that they should just be called pairwise scalar, then they would just neighbor the existing ones. And I don't think we have a complete list of them.
So max numeric pairwise scalar should be called max.
Number.
Number pairwise scalar.
And then
It might help if I know whiteboards are terrible with meetings, but so if you have left and you've got a vector, then you've got element 0, element 1, and then you'll also have right, which has 0 and 1. And so you do a plus operation here. So you get left dot 0 plus right dot 0, and left 1 plus right 1. When you have a pair, so this is the normal bi element. When you have pairwise or horizontal, you've got 0, 0, 1, and 0, 1. Left, right. And what it does is you get left dot 0 plus left dot 1, comma, right dot 0 plus right dot 1. And it continues for the entire sequence. So if you had like 2, 3, then 2, 3 would insert here before you process right. And so instead of operating on these pairs, you operate on these pairs. And so it's still a scalar, it's just a pairwise scalar coming from one register rather than two registers.
you're assuming not what scalar is.
Okay.
Scalar meaning a zero-dimensional element or one value. So a primitive like int float is considered a scalar as compared to an array, which is a vector.
But it's returning them in the vector register, so we have a vector type, or it's returning them in a
It's
scalar
returning
register, so
them
we
in
have
a vector register because that's how the registers work under the covers, and we don't have the support in the JIT to map integer values to vector registers.
Alright, so we're now at time, and there's still at least a page-wise worth of stuff remaining. So
Look how far down you got.
no,
Yeah,
well,
when he
yeah.
searched.
Yeah.
So what I will do is I will approve this one. I will paste in the comment what we reviewed, and then whatever the remainder is, we can review next time. But otherwise, let's make some progress here.
Yeah, the things that we missed were the new fuse, multiply, add, and subtract overloads for ARM64. So I assume those are just the same as before. Reciprocal estimate and step, same as before. So the only things that we've not reviewed yet that are new would be reverse element bits and multiply extend.
Yeah, I mean, I think we can probably just go ahead and hand wave and say anything that you're adding, just the overload on the ARM64 one of the existing one, it's make the same transformations and and just slide it under the rug.
In which case, it's we need to bring back reverse element bytes, reverse element bits, and multiply extend.
Is there a reverse bits routine?
Yes.
Okay.
So then, yeah.
And
so,
we need to bring back the step ones.
okay.
So 4 work items.
Yeah, and then is anything other than bits unique to 64?
Multiply, extend.
Okay.
Yeah. Multiply, extend, and reverse element bits are the 2 new concepts to ARM64. And then the work items from both are bring back reverse element bytes and the step ones.
So I probably didn't help the school bar.
Once it's long enough, adding more things doesn't really change things.
So so these are the comments that I added, and I pasted in the entire. Some reason there's a problem with the syntax highlighting now.
We could, oh, because you've got aim space. Oh, the namespace.
Let's take the syntax out. It's so easy to confuse. Let's end up being better.
I don't know why that changes the regex though. Like it seems a bit weird what they're doing, but anyway. All right, so. All right, I call it a day. Enjoy your lunch.
So we've still got the shift and permute to get through, and the ones with the interesting names because they're doing saturation and add and rounding all together.
Yes.
So unfortunately, I booked the next 2 weeks. I
Well,
think.
I'm out next week, so
So yeah, the next, actually, 3rd would be available.
Yeah, we will probably just need to have a bunch of one-off reviews.
Yeah, I mean, honestly, like if I think we can probably easily fill another 2 hours with just focusing on this. So
Okay.
like let's do one more thing at the 3rd, and then just finish this,
Yeah,
and then
so
hopefully we get over the.
Because we've also got the regular backlog to get through, plus features coming up
Yes.
that we need to review.
yeah.
That's what I'm saying. Let's just bundle it and then
Yeah.
be done with it.
1, 2,
All right. Bye bye, guys.
4, 5.